this video, for this question, let's read. There is a point between the Earth and the Moon where the net gravitational field strength is 0. At this point, the Earth's gravitational field strength is equal in magnitude but opposite in direction to the gravitational field strength of the Moon. So what does that mean? Well, it means that the Earth has its own gravitational field caused by its mass, and it attracts objects. The Moon also has a gravitational field caused by its mass, and at a distance, some distance between the Earth and the Moon, there must be a point where these two fields cancel each other out. And it must be closer to the Moon because the Moon's gravitational field is weaker. So it's saying, given that mass of the Earth divided by mass of the Moon equals 81, calculate how far this point is from the center of the Moon in terms of r, where r is the separation between the center of the Earth and the center of the Moon. So it really helps us to draw a diagram first of this one to describe what we're looking for. So when you've got a tricky question like this, it's going to help to draw a diagram. So that is the Earth, and then we've got the Moon somewhere over here, and then from the center of the Earth we're taking these as point masses. We are going to have some distances that we need to plot on here. The first distance is the distance between the center of the Earth to the center of the Moon, which it told us that that point is r. And then at some point, which we're going to call P, or some distance x, we've got point P where the masses cancel out, and we said that it's closer to the Moon. This is the Earth, this is the Moon, and then this distance here is going to be x, the distance from the center of the Moon to the point where the gravitational fields cancel each other out. And this distance we're going to call r minus x. Okay, so that's what we've got there. Now we can start to answer the question. We know what we're going to work out. So at this point P, the gravitational field strength of the Earth is equal to the gravitational field strength of the Moon. So G, so at point P, G of the Earth is equal to G of the Moon. We also know that G is equal to big G m divided by r squared. So we can make a new equation where we say G m of the Moon, or of the Earth in this case, divided by, which is r minus x to point P, isn't it, m? And then that is equal to G of m, which is big G m of m, divided by the distance to point P, which is x in this case. And we've got to remember that this is squared and this is squared. Okay, so that's what we forgot. Okay, so we want to put x, the g's are going to cancel, we can see that straight away. So g's have cancelled. We're going to bring x up here and me down here. So we get x squared divided by r minus x squared equals m of m divided by m of e. Okay, so we just flip that round so we get the m's on the right side. So r minus x squared divided by x squared equals m of e and m of m. We said earlier in the question that mass of Earth divided by mass of Moon is equal to 81, and we can do this step at the same time. This is squared, so we take the square root. So r minus x divided by x is equal to the square root of 81. Square root of 81 is 9. R minus x equals 9x. R equals 10x. Or we want to express x in terms of r, so x equals r over 10. And that's our final answer.